So, knowing the derivatives of the inverse trig functions, we can come up with some new integration formulas. So we know that the derivative of inverse sine is 1 over square root 1 minus x squared. So if we integrate this, then we should get back to inverse sine. And then the derivative of inverse tangent is 1 over 1 plus x squared. So if we integrate this, we'll get back to inverse tangent. And no one really uses this one. I don't know why I put it here. So let's look at some examples. So we have this integral, and right away there's no radical, so we can tell that it's probably going to use the inverse tangent one instead of this one. So basically we need it to be 1 over 1 plus and then a letter squared. So we need to get rid of this 3 and this 25 and make this just one letter squared. So to do that, we can factor out a 25 from the denominator, since we know we want this 1 here, so we factor out the 25. And then 16x squared becomes 16 over 25x squared. And then we can move these constants, 3 over 25, out of the integral. And then now, since we need just one letter squared, we can make a u sub. So if we make u 4 over 5x, u squared will be 16 over 25 x squared. So then we get dx is equal to 5 over 4 du. So make these substitutions, and then we get 3 over 20 integral 1 over 1 plus u squared du. Now this we know, this integral is just the inverse tangent. So we integrate, and don't forget the plus c. And then u was 4/5 x, so just plug that back in, and then you get the answer. So the next one, again, there's no radical, so it's probably inverse tangent. So just like this, we can't really do much with it. We can't u sub, and we can't directly use a inverse formula. So what we can do is split the integral up by splitting this fraction. So we can split it into the integral of x over x squared plus 4, and then the integral of 4 over x squared plus 4. And if we do that, with this first one, we can just use a regular u sub. If we make u x squared plus 4, then the dx is equal to du over 2x, so the x's will cancel out. And we'll just be left with 1/2 integral of 1 over u du. Now in the second one, we can do it like we did the first one. We know we need this 4 to be a 1, so if we factor out a 4 from the denominator and the numerator too, we can just move this out. We get 4 over 4 is 1, integral 1 over 1/4 x squared plus 1. So then we need this to be just one letter, so we make a u sub. If u is 1/2 x, then u squared will be 1/4 x squared. So we just make that u sub, and then now we're ready to integrate. So here we get 1/2 ln of u, and here we get 2 inverse tangent u. And remember, these two u's are actually different. This one was x squared plus 4, while this one is 1/2 x. So we replace the u in terms of x and add the c, and that's the answer. So this last one has a radical, so it's probably the inverse sine identity. So we need 1 over the square root of 1 here, minus something squared. So again, we want this to be a 1, so we can factor out the 4 over here, and then we can split this radical up to get square root of 4 by itself, which is just 2, and then move that 2 out to get 1/2 on the outside. And then to get just one letter, we make the u sub 1/2 x cubed, because this squared is 1/4 x to the 6th. And this cancels out the x squared on the top by making this u sub. So we substitute it in, and then we get 1/3 the integral of 1 over the square root 1 minus u squared du, and we know this integrates to the inverse sine of u. So then we replace u with 1/2 x cubed, add a c, and then that's the answer.